Think of a map of India. You probably picture state borders, highways, and major cities. But if you could zoom in close enough, you would see an entirely different geography, a living layer of microscopic communities covering the entire country. Looking at this map, India operates like a microbial continent. Because bacteria and fungi are highly sensitive to their environment, the distinct climates across the country create isolated zones where very different microscopic life forms thrive. Temperature acts as a natural filter for survival. In the alpine stretches of the Himalayas, the extreme cold creates a harsh baseline, meaning only specially adapted cold-tolerant microbes can survive. Contrast that freezing environment with the intense heat of the western deserts. Microbes cannot simply migrate to a new climate. They have to stay where the physical conditions naturally suit them. But climate is only half the story. To truly thrive, these microbes need a reliable food supply, creating a fermentation ecosystem. They rely on the specific resources, like native crops, that grow in their local region. The combination of physical geography, temperature, and local crops acts as an evolutionary filter. It dictates exactly which microscopic populations can naturally survive in every state. In the northern plains and western arid zones, the landscape is defined by vast dairy herds. These animals provide a massive, constant supply of milk, which serves as the foundational food source for the region's microscopic life. Inside regional drinks like lassi or chaas, a specific local habitat is created through traditional preparation. By churning milk in earthen pots, people set the stage for a very specific community of microbes to grow. Inside these dairy habitats, a group called lactic acid bacteria move in and take over. They become the permanent residents by rapidly feeding on the natural sugars found in the milk to secure their survival. Consuming milk sugar, the bacteria release acid, a process called acidification, causing the beverage's pH to drop. As the liquid acidifies, milk proteins clump into a thick, creamy structure. This acidity also creates a barrier. Harmful spoilage bacteria simply bounce off. This signature tangy flavor is the result of a deliberate survival strategy. It guaranteed the milk would remain safe to drink in a world before refrigeration. In the high rainfall states of the Northeast, the available resources shift away from dairy to abundant carbohydrate-rich crops like rice. To utilize these crops, the mission community uses botanical starter cakes. These are essentially concentrated seeds that carry a dormant population of microbes into the rice to create a beverage called apong. By slightly altering how the rice is prepared, humans engineer different microscopic realities. Using roasted rice and ash creates a dry, dense environment that favors one type of bacteria, while steamed rice in a liquid suspension invites an entirely different group. Reaching the rice, specialized sugar-breaking microbes wake up and expand. They immediately dismantle the complex, rigid rice starches, breaking them down into simple, usable energy. By making small changes to the heat, water, and minerals of their crops, people are actively designing entirely different microscopic habitats in their own homes. Some habitats don't need human-made starters at all. For a drink called kanji, people rely on the native microbes already living on the surface of raw root vegetables like black carrots. To make sure only the good bacteria grow, people add crushed mustard seeds. As they soak, the seeds release natural chemicals that are toxic to harmful bacteria, but harmless to the beneficial ones. As the bacteria break down the carrot's cell walls, they flood the water with a deep purple pigment. This process releases antioxidants from the vegetable, making them easy for your body to use. The bacteria use the vegetable's natural sugars for fuel, leaving behind a low-sugar, nutrient-rich tonic. Because the mustard seeds filtered out the bad invaders, the liquid is left naturally protected and safe to drink. In the intense heat of the southern tropical coasts, the climate accelerates all biological activity, meaning bacteria multiply incredibly fast. To sustain beneficial bacteria in this climate, local populations use dense finger millet or highly diluted spiced buttermilk. Spices like curry leaves and garlic are added to act as a necessary filter. The essential oils in these ingredients stop unwanted microbes from growing, ensuring these cooling, water-rich drinks stay pure and safe. Because they've adapted to their local environments, these bacteria have developed sticky, acid-resistant outer walls. This perfectly equips them to survive the harsh environment of the human stomach. Once they pass through the stomach, the microbes firmly anchor themselves to the lining of the human gut. Here they continue their work, fortifying the walls, producing helpful acids, and communicating with the immune system. When you drink these regional beverages, you are bringing a community of bacteria, shaped by the local environment over centuries, directly into your own internal system.